Okay, in this lesson we're going to be looking at properties of logarithms. Previously we were just introduced to the definition of logarithms. Today we're going to look at some properties, and we're going to use those properties to manipulate logarithmic expressions. So you could start with the warm-up if you'd like. You could pause the video for now. I'm going to just wait for 2 seconds and then I will show the answers. Okay, we'll move on now. We're going to look at one of the first properties here, and we're going to prove this one first. Let's look at this log, or this expression. Log 2 plus log 3 is equal to 10. And remember, when there is no base shown, we have an implied base of 10. We're going to take both sides of the equation. We're going to take 10 and raise it to the power of this left-hand side. We're going to take 10 and raise it to the power of x. Now I'm going to use my exponent property. We have an addition of exponents here, basically. 10 raised to the power of a plus b is equal to 10 to the a times 10 to the b. So this is just the reverse of our exponent property, which allows us to take these two terms here and combine it into this single term by adding the exponent. We kind of go in the other direction instead. Now, notice this. We have 10 raised to the power of log base 10. And remember, these are inverse operations, so we get, as a result of this, just simply 2. And for this next part of it, we have the same thing. We get 3 here as well. So now the next step, let's turn this into a logarithmic form. And so I have log base 10 of 2 times 3, and I'm leaving it written as 2 times 3 for now, and you'll see why, is equal to x. So what we have here, we can see that we started at the very top. We started at the very top with log 2 plus log 3, and we found that it was equivalent to log of 2 times 3. So that leads to our first property. It's our product property. If I have a product here, I could turn it into 2 pieces, 2 smaller pieces, and I add them instead. So this multiplication, this product, becomes addition. And with division, guess what happens? It turns into subtraction. I take this divided term here, m divided by n, and it turns into log of m minus log of n. And now if I have an exponent here, this exponent term is going to become multiplication outside of the log. The way I think of it oftentimes is I just pull this log value right outside. It just pops right out. So let's see how we can use it. Suppose we are already given these initial values of logs. We can use these values of logs to find log of 15. 15 is made up of 5 times 3, so we can write it as log of 5 times 3, and that's equal to, by using the property up here, it's equal to log of 5 plus the log of 3. Now we use our table. One of the values is 0.7, the other value is 0.48. We add the two. Adding is very simple, 1.18. Next example. Log of 2.5, that's equal to 5 divided by 2. So I'm going to express that as log of 5 over 2, which is, by this property up here, I can turn it into a log minus a log. So I have log 5 minus log 2. Log 5 is 0.7, log 2 is 0.3, and so I just subtract these. These are easy to subtract. I get 0.4 for log 2.5. Last example here, log 32. In this case, I remember it's 2 to the 5th power. So I'm going to write that log to 2 to the 5th, and now I use my other property up here. I have my exponent here, which then can be kind of pulled out. So now I have n times log of m. So I have 5 times log of 2. Log of 2 is 0.3, so I get 1.5. So again, you can give some of these a try. I'll give a little hint on a couple of them. Log 100. So I could rewrite this as log 100 minus log 2. And log 100 is not given. It's not one of these that are given up here, but we know what log 100 is. Remember, it's log base 10 of 100. So 10 raised to what power gives me 100? Well, that's 2. So that's the little hint. You can go ahead and do these other problems here if you'd like to. I'll just kind of quickly go through the answers and get to the next little part of the lesson. We can expand expressions as well, so we can go, in this case we have variables in here. So let's expand it using the property where we turn the division into subtraction here. Okay. We can keep going though. We could turn this multiplication into addition. Multiplication right in between here, between the 5 and the x cubed. We turn that into addition. And now we need to deal with this exponent here. We could bring it out here. So that becomes, right here, 3 times the log of x. Okay, so go ahead and try to expand these other ones. I'll show the answers here as well. Now let's talk about this last topic. On a calculator, there is no log 6 button. We have log, which is log base 10. We have natural log, which is log base e, but we don't have log base 6 as a button on the calculator. So this is how we solve that problem. We can calculate log base 6 of 25 by calculating log base 10 of 25 divided by log base 10 of 6. Or we can use the natural log. We can say natural log of 25 divided by natural log of 6. And actually any base. We don't have any base on a calculator, but basically any base. Log to the base b of 25 divided by log to the base b of 6 is going to be the same as log base 6 of 25. Here's a little proof of that. Okay, let's start with this log base 6 of 25. Now let's just convert it to exponential form. All I did here, 6 to the power of x is equal to 25. Now I'm going to take the common log of both sides. And this is again log base 10. But this is the button I have on the calculator. I have a log button. Now using our exponent property, we pull this x right on out here. And now I have x times log 6 is equal to log 25. And now I divide both sides by log 6, so I get x is equal to log 25 divided by log 6. So now I've turned this log base 625 into this, which allows me to plug that into my calculator. So if you have a calculator, you can just press your log button. You might need to use a parentheses, 25, another parentheses, divided by log parentheses 6 parentheses equal. And that should give you your log base 6 of 25. Give it a try.